I'm going to be doing a quick tutorial on organic chemistry nomenclature, so IUPAC rules. So the first thing we do when we want to name our molecule is we want to identify the parent chain. So the parent chain will be your longest carbon chain with your functional groups. So remember that your parent chain absolutely must contain the highest priority functional groups. So down here, we've identified the parent chain here in purple, and since there's 8 carbons, it's going to be oct. And we've identified over here that the double bond is our highest priority functional group, so that's going to get an -ene suffix. Next thing we want to do is we want to number the chain. So we're numbering the carbons with the highest priority, starting at the lowest number. So in this case, again, we're looking at the -ene being the highest priority, so we start over here at 1 instead of starting over here at 1. So we're labeling left to right in this case. Next, you want to determine the names of your functional groups or side chains. So we've identified 4 functional groups or side chains in this case. We've got a phenyl at position 3, we've got an isopropyl at position 4, and then at 6 and 7 we have chloro, and remember there's 2, so it'll be known as dichloro. And when we put it all together, we're going to alphabetize the side groups. So in this case, phenyl's P, isopropyl is I, dichloro, we're looking at, remember di, tri, etc., these don't count, and neither do the isomer prefixes except for iso. So in this case, we are counting the I in isopropyl, but if it were sec-butyl or tert-butyl, it would not count in your alphabetical order. So in this case, we're looking over here at the P, the I, and the C, and it comes out to 6,7-dichloro, 4-isopropyl, 3-phenyl, 1-octene. So let's try an example. So step number 1, we want to identify the parent chain here. So in blue, I'm going to highlight my parent chain. I know it looks to be like this, right? However, because this right here is sneaky, it's got 2 carbons on it, so that's actually the longest carbon chain here. So here is our largest carbon chain. It's 1, 2, 3, 4, 5, 6, 7 carbons long, so it's going to have the parent of hept, and there's no double bonds, carbon-carbon double bonds here, so it's heptan something. We can identify our priority here, which is the highest priority functional group, as a ketone, which is right here. So that's going to be known as -one. So that's what our parent name is going to be, heptanone. Next, we are going to number our carbon chain. So again, we want our highest priority functional group to be at the lowest possible number. So in this case, our ketone is the highest priority functional group, so we want to give that the lowest possible number. So we're starting over here at number 1, 2, 3, 4, 5, 6, 7. If we labeled it the other way, so left to right, the ketone would be at position number 4, which is not as low as it can go. So we're labeling right to left in this case. Now we are going to identify the other functional group. So we've already got the ketone. So what else is left? We've got 3 other side chains, which I will put in orange. We've got position number 2, position number 4, and position number 5. So position number 2 is a methyl, right? It's actually also at position number 5. So we've got 2, 5, di, because there's 2, dimethyl. And then at position number 4, we have a bromo. Now it's time to construct our name. And when we construct the name, we're going to be putting everything into alphabetical order. So we're looking at the M in methyl and the B in bromo. And so because B comes before M in the alphabet, it will be 4 bromo, 2, 5 dimethyl, Our parent over here we identified as heptanone. Again, we need to label our ketone, which is at position number 3 right here. So 3-heptanone. And that is how you would label this molecule.